How are you, my friends? This is Basic Math Terms, part 27 about conic sections. These terms are coming from lectures 37 to 40 from the pre-calculus course. The terms are conic sections, parabola, focus, directrix, and focal diameter. This is from lecture 37. Then we go to the ellipse, foci, vertices, minor axes, eccentricity, and major axes. Hyperbola, transverse axis, fundamental rectangle, conjugate axis, central box, asymptotes of hyperbola. Then finally, we will see the general equation of shifted conics and degenerate conics. Now, this is a conic sections. We have a cone, and the intersection of this cone with a plane can result in an ellipse. If you put the plane like this, then the intersection between the cone and the plane is an ellipse. If you place the plane this way, then the circle is the intersection. If you place the plane in that form, it will be parabola, the intersection. Or if you put all this plane, then this is a hyperbola. The graph here are called hyperbola. This is only a diagram. Now let's look at geometric definition of a parabola. We start with parabola, ellipse, then hyperbola. Parabola is the set of all points. So we have points on this parabola like A, B, V, M, N that are equidistant. The word equidistant we have seen in the algebra. It means the same distance. Equidistant means the same distance. From a fixed point is called focus. So this is a focus here, and the fixed line is called directrix. So we have a directrix here, line. We have a point here, we call it focus. Any point on the parabola, A, B, V, M, N, any point on this red graph, the distance from this point, like A, you see, distance from A to F, distance A to F, equals the distance from A to L. Also, the distance from B to F, same distance from B to L. Same thing for M, same thing for V. Okay. So the vertex V is halfway because this is V is a point on the parabola. The distance from V to F, same distance from V to L. So V is the midpoint between the focus and the directrix. The axis of symmetry, it's a line through the focus and perpendicular to the directrix. We call this the axis. It passes through the middle of the parabola. Now find the focus and directrix of the parabola whose equation is this: minus y minus 5 squared 2 times 14x plus 5y minus 25. So this parabola is lecture number 37 of the pre-calculus course. We have to rearrange this equation, guys, here. Rearrange it. You know how to rearrange it. Y minus 2 squared, expand it. Y squared minus 10y plus 25. There is a minus outside. Multiply here by 2 times 14, 18x plus 10y. And then after you rearrange completely, you get y squared is equal minus 28x. And we know the formula for this horizontal parabola will be y squared is equal 4px. That's the formula here. So y squared is y squared, x is x. That means minus 28 is equal to 4p, the coefficient. Divide by 4p will be minus 7. So it's opening to the left. Okay, so the focus now, minus 7, 0 here on the x-axis. And the directrix, it's a line x equals 7. Focal diameter of a parabola. If you have a parabola here, draw a line, see line, through the focus. This yellow line here, see this line through the focus, we call it focal diameter, FD. the distance for this, we call it focal diameter. The distance now, it will be absolute value of 4p. So it tells you how wide is the parabola. How wide. If you know p, then you can find 4 times p. Take the absolute value because p is sometimes negative, sometimes positive. Okay. This is to show you if we have large p and small p. See, if we have a function here, parabola, y equals 2x squared. See, the p is 0.125, as we did in the example. If p is large, then the parabola is wide. If p is small, then the parabola is narrow. So this p here is 0.125, this p is 0.5, this p is 1, this p is 4. You see, if it is big number, it will be wider. Now, what is an ellipse? Ellipse, set of points in the plane where the sum of whose distances from two fixed points is constant. So if you have any point on the ellipse, P, you find P, the distance from P to F prime, plus, you take the sum here, you see the sum, plus distance from P to F is equal to A. See, that's the constant 2A. So any point on the ellipse, the sum of the distances from this point to each one of the foci, see the foci are always located on the major axis. So we have focus 1, focus 2, then we call them foci. We don't say focuses. And this one where the foci lie, we call it major axis. And the minor axis, this small one. And the whole shape, we call it an ellipse. These are the vertices, V, A0, another V prime, minus A0. So this is vertex, another vertex. We call them vertices. We don't say vertexes. Ellipse has two axes of symmetry, as we said, the major axis and the minor axis. This is the summary of ellipses formula. If you have horizontal ellipse like this, you can imagine it. It will be x squared over a squared plus y squared over b squared is equal to 1. Always a greater than b. If you have the major axis vertical like this, the ellipse, you can imagine that. It will be x squared over b squared plus y squared over a squared is equal to 1. A greater than b always. So if the bigger number under the x, it's horizontal. If the bigger number under the y, it's a vertical. And to find the foci in ellipses, always you can use this formula, c squared is equal a squared minus b squared. If you know a squared, b squared, subtract b squared from a squared, you will get c squared. And then you can proceed. Eccentricity, it's a number. C over a, this is the formula for the eccentricity. It measures roundness of the ellipse. So the ellipse can be very long and thin, or the ellipse can be almost a circle, It's not a circle. So if E is approximately 0, close to 0, ellipse is almost a circle. See, like here we have ellipse 1/2. If ellipse is close to 1, the ellipse is long and thin. So the eccentricity is E between 0 and 1 for the ellipse. Between 0 and 1, not 0, not 1, any number between. So the eccentricity is a measure of how stretched the ellipse is. This we call eccentricity. What is a hyperbola? Hyperbola also, set of all points x, y in a plane, where we have here points on the hyperbola, P to focus 1 minus, see the difference here, minus the distance from P to focus 2. So we have foci, F C0, F prime minus C0. And there is a center here. Center is the midpoint of the line segment F prime, the midpoint also of the vertices V prime. This is the center. What else? We can, in the hyperbola, we can draw what we call here central box. This is a central box. Some books, they call it fundamental rectangle. They are the same meaning. So the formula, the area for fundamental rectangle here on the right side, you can see 4AB. Why? From the center to the vertex here is A, and from this, the same center to the other vertex is minus A. So the distance here is 2A. Same thing, this is 2B to draw the rectangle. 2B times 2A, length times width will be 4AB. Now, asymptotes, we have two asymptotes like this, two lines. We will find them. I will show you how. Y equals plus or minus B over AX if the hyperbola is horizontal like this. Transverse axis is the line segment VV prime. Only this part here, from vertex 1 to vertex 2, or V to V prime, we call it transverse axis. And this constant is still 2A. Now, this is the standard form of equation of hyperbola, x squared over a squared minus y squared over b squared. Remember the ellipse, it was a plus here. There are two differences between the equations. In the ellipse, we have a plus. In the hyperbola, we have a minus. In the ellipse, always a greater than b. In the hyperbola, no. A can be equals to b. So this can be 9 and 9, 16, 16, 20, 20, 75, 75, 60, 60. Or a less than b, or a greater than b. So we don't care here in the hyperbola. So how do we know? We go under the positive is a squared. I explained transverse axis. This is horizontal. Vertices, conjugate. Conjugate axis is this one here, from B to minus B. This is axis, conjugate axis, we call it, conjugate axis. This is the other hyperbola where we have y squared over a squared. That's a vertical. See, transverse axis is vertical. So it's up and down. Y squared over a squared minus x squared over b squared is equal to 1. If you need more examples on hyperbola, you can check lecture number 39, the one before the last lecture of pre-calculus. And also for the ellipse, you can check lecture number 38. Okay. Quick way to find the asymptotes. This is very quickly nice here to check the asymptotes. See, if you draw any hyperbola, you should have two asymptotes. Quick way to find them, replace 1 by 0. After you find the equation here in standard form, there is a 1 on the right side. Replace it by 0, solve for y easily. You don't have to remember any formula. So let's take an example here. X squared over a squared minus y squared over b squared is equal to 1. Replace 1 by 0, I just put 0. Only to find the asymptotes. Solve for y, take this on the other side, multiply by b squared, take the square root, y will be plus or minus b over ax. So whatever hyperbola you have, you can find very quickly the asymptotes. Now, to find the eccentricity of a hyperbola, you can use this formula, E equals C over A. C is the distance from center to the focus, and A is the distance from center to the vertex. C is bigger than A, so for hyperbolas, E greater than 1, different from the ellipse. Narrow hyperbolas have E near 1, like this one here. Wide hyperbolas, they have large E. So this one E 1.1, this one E is 2, this is very wide, E equals 5, etc. It will be E greater than 1. General equation of shifted conics. This is very important. If you see any equation like this, ax squared plus cy squared plus dx plus ey plus f is equal to 0. You have x squared, y squared, x and y. All the other numbers are constants, a, c, d, e, and f. Always you have to complete the square on x and y to decide what is the equation. So it can be parabola if A is equal to 0 or C is equal to 0. A and C are not both zeros because we will have only a straight line. So either A is equal to 0 or C is equal to 0 or none. Ellipse, if we have A and C have the same sign, A and C, both positive or both negative. Hyperbola, if A and C, they have opposite signs. One is positive, one is negative. If we have a circle, if A is equal to C, then we can complete the square. So these are 4 possibilities here. Now the other 3 possibilities, 5, 6, and 7, we call them degenerate conics. That means they are not true conic sections. We call them degenerate conics. So they can be single point or pair of lines or no graph. Always you have to complete the square on x and y. So if you have something squared plus something squared is equal to 0, that is a single point, only 3 and minus 4, whatever the numbers are. Or if you have something squared minus something squared is equal to 0, this is pair of lines because you can take this on the other side and take the square root of both sides. You will have 2 straight lines. Or no graph, if you have something squared plus something squared is equal to negative number. This is no graph. You can see all these and many other examples on lecture 40, the last lecture in pre-calculus course. I will leave you with a nice example on shifted conics. Suppose I give you an equation like this: 9x squared plus 36 is equal to y squared plus 36x plus 6y. What does the equation represent? See, you cannot decide by looking. You have to complete the square on the x and y after you rearrange it also. Now to complete the square, we have to rearrange the equation. 9x squared, bring 36 on the other side here, becomes minus 36x. Take 9 common factor, 9, and then inside x squared minus 4x, because in the completing the square, we have to have the coefficient of x squared and y squared should be 1 here inside the bracket. Y squared, take it on the other side, becomes minus y squared. Also take 6y on the other side, becomes minus 6y. Take a minus common factor. Then inside the bracket, we have y squared plus 6y. Leave the 36 is equal to 0, or you can take it on the other side, minus 36. It's up to you. Now, when we complete the square, we take the coefficient of the x, divide by 2, then we square it. And then we add and subtract. So minus 4 here, minus 4, divide by 2, minus 2, square it, 4. You add 4, subtract 4. 6y, take only the 6, divide by 2, 3. Square it. You add 9, subtract 9. If you need more examples on completing the square, please you can refer to lecture number 22 in the algebra course. So we will have 9 in the bracket here, x squared minus 4x plus 4. This is complete or perfect, we call it. X minus 2 squared, and then there is a minus 4. Leave it. Y squared plus 6y plus 9, it becomes y plus 3 squared minus 9. Now you distribute the 9 here, and you distribute the minus there. Minus with the minus 9 becomes plus 9. Now you cancel minus 36 and plus 36. Take 9 on the other side, becomes minus 9. That's a little trick. You have to be careful here. You have to divide by minus 9, both sides, like this here. You see, I put it in details. 9x minus 2 squared divided by minus 9, y plus 3 squared divided by minus 9, minus 9 divided by minus 9, because we have to rearrange it. Now, this is one on the right side, finished. There's a minus, and minus 9 becomes plus. So we put that at the beginning here, y plus 3 squared over 9. And this minus 9 will be canceled. So we have minus x minus 2 squared over 1. So what is this equation? Hyperbola. The center, 2 minus 3. X always goes first, then y. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.